I wanted to cover molecular orbital theory because I know it is a difficult topic, and many of us forget it once we have learned it. And so I have used inorganic molecules to help us remember what molecular orbital theory is. So here I'm going to do a MO diagram for N2 minus. Okay, so in order to do this, you need to think about how many electrons each nitrogen has in its atomic orbitals. And then we need to draw out the atomic orbitals like I have. So the atomic orbitals are on the outside. Okay, and the molecular orbitals are in the middle. To do this correctly, you have to make sure that the number of atomic orbitals you put in is the same number of molecular orbitals you get out, and you need to make sure you maintain the right number of electrons. So the number of electrons in your atomic orbitals should be the same as the number of electrons in your molecular orbitals. Okay, so when thinking about nitrogen, we know that it has 2 electrons in the s orbital, and so both nitrogen has 2 electrons in the s orbital. So that means from the atomic orbitals, I'm bringing in 4 electrons, and I'm going to fill in lowest energy to highest energy, like so. Okay, so what I have done is I have filled in the lower energy, which is my bonding molecular orbital, and then the sigma star. Anytime you see a star, we're talking about anti-bonding here. Okay, so those are higher energy orbitals. All right, now we have to think about this p orbital. Okay, and we know that nitrogen has 3 electrons in the p orbital. So each one should have 3. Okay, now we have to pay attention to something. I have told you that I want the molecule N2 minus assessed. And so since it's a negative charge, I have to account for that extra electron, and it doesn't matter which side you put it on, just put an extra electron in your atomic orbital in either side. And so now I have 7 electrons in my atomic orbitals in the p, and I'm going to put them in lowest to highest. So there's 2. Okay, and remember now when you have 2 orbitals at the same energy level, fill in single spins and then backfill in with the opposite spin. So that's 4, 5, 6. Okay, and then the last one, 7, is going to go into a pi star molecular orbital. Okay, so this is how you draw the MO diagram for a molecule like N2 minus. Now, after you do this, you want to assess the bond order. Okay, and to assess the bond order, you have to do a calculation. So bond order equals 1/2 the number of bonding electrons minus the anti-bonding electrons. Okay, so to calculate it, we have to count how many bonding. And so we have 2, 4, 6, 8. So 1/2 times 8 minus, now we have to count how many anti-bonding. 2, 3. Minus 3. Okay, and so we do the calculation, and you say 1/2 times 5. And so bond order equals 2.5. Okay, and so what do we use the bond order for? It tells us if the molecule is considered to be stable or unstable. A stable molecule will have a positive value, and an unstable molecule will have a value of 0 or lower. Okay, and so in this case, 2.5 is a positive value, so N2 minus is considered to be a stable molecule.